Till now in this chapter, we talked all about gases. In this video, we'll be talking about liquids. So as we know, there are three states of matter: solids, liquids, and gases. Liquids and, basically liquids according to the kinetic molecular theory of gases. The molecules of liquids are relatively closer to each other and they have a stronger intermolecular force of attraction than compared to that of gases. So compared to gases, liquids also have less amount of disorderedness and there's going to be a little more order in liquids than gases. So in this video, we'll be learning about or rather, I think we'd be re or recapping on the various properties of liquids. First one is volume. As we know, liquids have a definite volume and they take the shape of the container. Gases, on the other hand, they will take the shape of the container and they will fill the whole container, and so they don't have a specific volume. Liquids have a specific or definite volume, and because the intermolecular forces in liquids is relatively higher than that of gases, because of that, like if you remember, and if you look, if you've looked at or watched one of the videos, the first chapter where we discussed about solids, liquids, and gases, there was this comparison that I made. Even in a small box, the amount of gas which is present, when you leave it out into the entire a big room, then the volume of the gas will become the entire room itself. So the volume of a liquid is a definite one. Next is density. Now, density, first of all, compared to liquids and gases, liquids are more dense than gases because they are closely packed. So density of a liquid is considered to be about 1,000 times that of, or rather greater than that of the density of a gas. Now, again, the reason they're dense is because of the fact that the intermolecular forces are stronger and intermolecular spaces are lesser. So these molecules are closer than that of gases. And one more thing, density will decrease with increase in temperature. And that's because when the temperature increases, the kinetic energy of the molecules will increase. So they start moving more freely. And because of that, the density will decrease with increase in temperature. Next is compressibility. Now, if you think about gas, when we try and compress it, there's some amount of free space for these molecules to get for it to use up. On the other hand, liquids are going to be less compressible than gases, and a very huge amount of pressure is required for a significant for an increase in the compressibility. Okay, so for example, if you remember when we talk about the isotherms of carbon dioxide, for us to compress a small amount of liquid carbon dioxide, it led to a huge increase in pressure. Next is diffusion. Diffusion is basically the ability of particles to mix up. So compared to gases, liquids obviously will diffuse at a much slower rate than that of gases, and these are closer to each other, and so they will not undergo diffusion to that extent. But these molecules are far apart, far enough for them to undergo diffusion in the first place. However, in case of gases, it's easy for gases to undergo diffusion, or it is easy for it to mix up because the molecules are farther apart. So there are no obstructions for diffusion as a process to take place. The last one is evaporation. Now, evaporation and boiling, there's always this confusion, right? Evaporation is if you keep a vessel outside and the water starts evaporating from it, that is, or rather the water escapes into the atmosphere, that is evaporation. Boiling is you heat the particular beaker or you heat a vessel and you provide some amount of heat to the mixture, and that undergoes, that leads, when we talk about water, it reaches 100 degrees Celsius, the water molecules start escaping into the air. That's boiling. This is a basic idea that you have, but we'll be discussing about that in the next video in detail. But evaporation, so the reason evaporation takes place is because even if there are a certain amount of intermolecular forces between the molecules of a liquid, they do have a tendency to escape. So these molecules have a tendency to escape, and that is referred to as evaporation. So this conversion of a liquid to form vapors at room temperature is called as evaporation. Evaporation is a room temperature phenomenon. You're not providing extra heat and it takes place in room temperature. With that, we're done with the discussion of various properties of liquids. In the next video, we'll be talking about one very important and unique property that you've not learned until now, that is vapor pressure.